Right, I hope all of you can see my screen. Right, so let's begin. So hello everyone and welcome to the fifth session of ISTQB CTFL training. So I hope so far whatever we covered in the previous sessions is clear and you are enjoying this training and finding it useful. So let's have a recap. So last time we went through the psychology of testing, and with that we finished the first module. We also started the second module and we started covering software development lifecycle models. So in last one, we just went through the type of SDLC models which are commonly used nowadays. Not only nowadays, but like which are the common SDLC models which are being used. Okay. So today we will continue with the SDLC models, and we will also cover test levels in it as well. So whenever, in last session, we did cover the common SDLC models. And today, now we will continue the same topic, but now we will talk about that when we are selecting an SDLC model, then what are the characteristics based on that we select and adapt a model? So what is the criteria for that? And high level criteria is that it depends on the context of the project and the characteristics of the product. And the factors, the main factors which contribute to the selection of an SDLC model are project goal. So it depends that what are you trying to achieve from that goal? Is it, so how lengthy is the project? Do we have all the requirements for that? Do we have resources, etc.? And based on all these factors, we can define the project goal, and then we can say that, okay, now this is the model which will best suit this project. So yes, we can use this model. Second is type of product being developed. So when we are developing a product or a project, it depends that what type of project it is. It can be a very, let's say, a critical project, or where lots of security concerns are there, or there is a product for which performance testing will be a key thing and we have to perform that. Or it can be an internal document management system like CRM, etc. So it depends like what kind of project we are developing. The third one is business priorities. And in business priorities, there can be many factors inside this. And for example, can be the time. Let's say that we get few requirements and then the business says that, yes, this is what you have to develop, but we have only 2 weeks or 3 weeks to deliver this, because maybe marketing has already been done and already there is a marketing campaign which is already live, and a launch date is already been communicated. So this is something which we can't say that, okay, if the project or product is not ready and the quality is not good, then we can't deliver or we can't launch on that date. No, when we have these kind of tight deadlines, then we have to work in the reverse manner, that okay, what we can do to achieve that live date. So based on that, then of course, like waterfall model, those kind of models would not be a good candidate. Maybe agile model would be a good one. So business priorities also play a very major role. The fourth one is identified product and project risk. So in earlier session, I think in session 2, we did cover product and project risk briefly. That it depends that what kind of project we are doing and what are the risks associated with that. And the product as well, that let's say if there is a product which we are testing and we are not happy with the testing and there are many critical bugs in that product, then we can highlight that it's a risk to go live with these critical bugs. It will affect the quality of the product. So we have identified a product risk. On the other hand, a project risk will be that we are short of any test resource, and based on that, the project which was supposed to be finished in 2 months, now it will take us 3 months to complete that project with the given resources. So that's how, depending on the product and project risks identification, we can choose which SDLC model we should be using. I hope this part is clear. Right, so next, depending on the context of the project, it may be necessary to combine or reorganize test levels and or test activities. So in last session, we did cover the test activities which are associated with a test process. And today we'll be covering the test levels as well. So now what we are learning is that depending on what kind of project we are working on, sometimes we can also combine different test levels and test activities, or maybe we can reorganize the order they are being done as well. So there is no specific rule that it has to be done in a certain manner. We can mix and match test levels and test activities, and we'll get to know more about it as we will go further into these things in details. Secondly, SDLC models. Yes, we can also combine the SDLC model, and one example which we covered last session was the agile model. Like agile methodology is a very good example where we are merging an incremental model and an iterative model. So similarly, we can merge the SDLC models as well based on the requirement of our project. Right, so now we will come to test levels. So the definition of the test level in the ISTQB glossary is: test levels are groups of activities, test activities that are organized and managed together. So previously we did cover test process, and we also learned that what are the test activities for those test processes. And now what we are doing is that we are learning about another layer in between, which are test levels. So we have test process, then test levels, and then for each test level, there can be certain test activities. Okay, so let's see that what test levels are there. So there can be other test levels as well, but for this foundation syllabus, we will be going through these 4 main test levels, which are component testing, integration testing, system testing, and acceptance testing. Now, if we see this diagram, which is in a pyramid shape, the reason why this is presented in a pyramid shape is because in the order it is being presented, if you see that the component testing has the wider part because that's at the bottom, and then as we go up the pyramid, it's becoming narrower and narrower, because the idea of performing testing according to these test levels is that when you start at the base is very solid. If the foundation is solid, then as you build any project on top of that, then we don't need the testing which we will be do on top of that will keep on reducing, because we are, from the very beginning, we are ensuring that the quality is great, and this way we will be getting few bugs, hopefully, on each level. Unfortunately, in most of the projects where stress is not given on component and integration testing, and the first time a project is tested in the system testing level, where basically the testers start doing testing, that's the system testing level. And if you see that, ideally what should be the testing window for that, no, we don't pay attention on component integration level. So all the load is now on the system testing level, and at that time, then if we identify the errors, then of course that's expensive and it takes longer as well. It can also affect the project timeline too. So ideally, this is how much effort, or the ratio you can say, should be allocated for each test level. Right. Secondly, for each test level, there are few attributes, and we will go through all these attributes today for different test levels. And first of all, we will go through the definition of each test level. Then each test level has a specific objective. Then what are the requirements of that test level, which will be test bases. Third one is test object, that what we actually need to develop in order to test the test basis, which is the requirement. Fourth is typical defects and failures, that what kind of defects and failures we should expect in that test level. And the last one is approaches and responsibilities, that any testing which is done on that specific test level, who is responsible for that, and what are the main approaches for testing. So we will go through in detail, and these are the 5 main attributes which we will go through for each test level. Apart from these attributes, it's important to remember that for testing at each test level, we should be having a proper test environment. So as we will go through each test level, we will also cover the test environment as well, that okay, now for this kind of test level, what kind of environment ideally we should be having. Now this is the first test level which we will cover today, and the other 3 we will cover in the next session. So let's first see that what is component testing. So component testing is also known as unit testing or module testing. So if you hear someone saying module testing or unit testing, is nothing different than component testing. So it's the same thing. Let's go through the definition of component testing. Component testing focuses on components that are separately testable. So let's take an example that we have a requirement of a user registration page. So let's say that if we are registering for a system and it has different stages, different sections. So usually if you have filled any registration forms, so usually there are different sections like personal details, employment history, education. So these are the 3 sections we are taking as an example as a requirement of a user registration system. So now these 3 different modules are our components. So personal details is our component A. Then we have a component B, which is employment history, and then component C, which is education. So now all these components are requirements of user registration page, or you can say system. And what we can do that we can split it into these three components and we can build them separately, or maybe one developer can develop all these three components, but these are individual components. They are not dependent on each other. So let's say that if one developer is working on all these three components, that developer can start with component C first and then develop A and then B. Or there can be three different developers. One can take component A, component B, component C. So what we have done that when we have our a requirement, we have splitted that functionality into different smaller units which can be tested separately, and then later on then we can integrate them, because like that our scope of testing will be limited, and we can pay more attention that if that component is developed based on the requirements. So at this stage all these components can be tested separately. I hope this concept is clear. Secondly, in component testing, we'll also come across different concepts like stubs and drivers. And let's first go through the definition, then I will also go through the other terms which we can use instead of stubs and drivers. So definition, component testing focuses on components that are separately testable. So this is the definition of component testing, which we already went through. So now sometimes we can also have a criteria where we have different components. Let's again go through component A, B, and C. But in this case, we have a dependency on other components. If we go back over here, we said these three components have no dependency on each other. So we can do it in any order. Right, over here, now we are saying that component A has a dependency on component B, and component B have a dependency on component C. So now let's say that component A is developed, component C is developed, but component B is not yet developed. But because A has a dependency on B, we can't test component A fully. So in this case, what we can do, one case is that we wait for the component B to be developed and then we test component A. Or what we can do is that we can develop a mock object over here named as component B, or named as employment history. And then without building the entire component, we can just have a mock object, and that can be called. If it's a function, we can call that function in component A while we are testing this component. So what will happen then, it will not break the flow of testing which we require to do in component A. If we need a parameter, any specific one parameter from component B only, and it's holding off our entire testing for component A, we'll just create a mock object and we will just maybe just add a parameter over there, and we can call that parameter in component A. So now over here, when a main component is being called by another component, it's known as stub, because over here, this component B is being called by the main component, which is component A. So in this case, this will be known as a stub. A stub can also be known as a mock object, and the same is with driver as well. So we'll come to the driver now. Now, if we just take, let's say component B and component C. Okay, I can see there are some questions. Let's go through the questions first. what type of data, so Umair is asking, what type of data mock variable hold? Okay, so Umair, it can be anything. It depends that what kind of data we require for our testing of component A in this case. So for example, let's take an example that we have personal details over here. And in personal details, we have any field which also require a parameter from component B. So let's say that if we have an requirement of age over here, that we are taking date of birth in personal details and we are calculating the age of that person, then in component B, we need, if there is employment history, then maybe we are taking a variable from here that when that person started working, started his employment. So it can be that there is any field of like personal details and number of years of experience. We are just taking the number of years of experience over here. And then later on in this section, we are just splitting the employment history in detail. And so from over here, we just need the beginning of the employment history, like when that person started working, something like that, which is being fed over here. And we also need to uh, uh, check it with the age as well, that we don't want, of course, this will be an invalid case if someone is only 19 and according to the employment history or starting date, that person started employment maybe when he or she was 11 or 12. So if these kind of criterias or the functionalities are there, it's just an example. So which means that we need something from component B in order to test over here. So over here, then we don't need to build the entire component, and maybe we can just define one variable over here, beginning of employment journey, and that can be one variable, and that variable can be called over here. So it can be as simple as that. So in this case, because component B is called by component A, then it's known as stub, and the opposite is known as driver. So now if we take this part B and C, over here, component B is calling component C. So in this case, we had main component, which was being called by component B, but over here, this one is calling this. So it will be known as driver. So in both cases, stub or driver, only the position is different, but both of them are mock objects. These are known as mock objects. These are also known as test harness as well. So test harness is nothing else but a collection of mock objects or stubs and drivers. So you can come across these kind of terminology: stub, driver, mock object, test harness, service virtualization. If you have done any load testing, then you would be familiar that how we do load testing is that if you want to test a system with an assumption that 100 people are using it at the same time, then we use the load testing tools in which we have virtual users, means they are not real users, but we are creating a load in a way that we have those 100 virtual users, and it gives us the same load as real 100 users will be using that system. So that's why it's known as virtual users. Similarly, there are virtual environments. So if we have a specific infrastructure requirement and we don't have physical server, then we can just generate some virtual servers. If you are working from home and you are able to connect to your office network, then maybe there are some virtual servers which you are being connected to, depending on the way you are connected to the servers remotely. So these are the few concepts which you should be aware of. This might be a little bit confusing, but for this syllabus, you should just know these terminologies. You will not be required to go into detail until you go to an advanced level. So if anyone is not clear or is having any question, let me know, and then we will move forward. Okay, there is nothing, so I hope this one is clear as well. Let's go further. Right, so if you see on the right hand side, we said that there are 5 attributes to any test level. And now as we are going through our first test level, which is component testing, we will be going through turn by turn all the attributes, and we will start with our objectives. So in component testing, what is our objective? That what are we trying to achieve from component testing? So so by now, of course, we have learned that what is component testing, but now we will see that why are we performing component testing, and of course, what's the objectives. First one is reducing risk. So by performing component testing, we are reducing the risk as we are confident that the component's functionality is working individually. So if we have multiple components in a system, and each component has been tested individually and has passed the testing, then we are reducing the risk that when those components will be merged together, there is of course there is a risk. There might be anything due to which when they are working separately perfectly fine, but when we merge them together, then there can be a conflict, and that's another thing which we will go through later. But the risk is low that there would be any issue when we merge all the components. Second is verifying whether the functional and non-functional behaviors of the component are as designed and specified. Okay, so during component testing, what we are doing, we have a design phase, and then we are actually developing the product. Means we are coding, we are writing the code. So in component testing, what we are doing, we are comparing the written code against the design which is specified, and we are verifying that they both are in sync. So we are basically kind of doing traceability at that level, that whatever the code I have written as a developer, it's as per the design phase what we agreed. The third one is building confidence in the component quality. If we find defects during component testing and we keep on fixing it, obviously it will increase our confidence in the quality, and it will also show that the component is working as expected. So with each new defect which is being fixed, our confidence level will increase. Fourth one is finding defects in the component, which is also related to the next one, which is preventing defects from escaping to higher test levels. So when we find defect during component testing, we fix them, and again we retest it. And by doing this cycle, what we are doing is that we are not only finding and fixing the defects, we are also preventing the defects from escaping to the next level, which is the integration testing, which we will do later. So right now in component testing, if we find defects, then there is a lower chance that the defects will go to integration testing. So if we just for a second go back to this diagram. So if we are doing this component testing over here, as we said that this is the base of the base test level. And if we do testing at this level in the best way, then there are chances that very few defects will go to integration. If we just skip this level altogether and just hope that everything works in integration, then that might not be a very good idea to do. So if we do proper component testing on individual components, then later on we'll have less defects in integration system and acceptance testing. Okay, so these are the objectives. Are there any questions? Okay, Umair is asking why one is stop and the other one is driver if both are working the same. Okay, Umair, let's go through that slide again. Okay, so why they are different, as that's why I have written over here, so that because it can be confusing. Over here, component B is being called by component A. And over here, in this case, component B is calling component C. So the idea of having a mock object is the same. It's just that either that mock object is being called by a component or that mock object itself is calling another component. So is that clear? Right, okay, that's good. So we have gone through the objectives. And there are a few other things which we will cover as part of component testing before we move to the next attribute. That the component testing, what kind of testing it may cover. It can cover the functionality, which is the correctness of calculations. It's just an example, just to give you an example of that what can be the functionality testing. Then it can also cover the non-functional characteristics, for example, searching for memory leaks. And it can also go through the structural properties, for example, decision testing. And decision testing is when we have lots of conditional statements within the code, like if, else if, or switch statements. Right. So component testing, if we are doing component testing in an iterative and incremental, sorry, this should be SDLC, it's a typo over here. SDLC model, for example, Agile, then what we are doing, because it's a very fast moving and we are having iterations maybe every week or every 2 weeks, then the code is changing continuously, which means that if we are supposed to do component testing with each iteration and we have so many components and every time we have to recheck all the components, then it will be a very tedious job and it will be very difficult to do it manually. So it will be good if we automate the component regression testing. What is regression testing? That we are making sure that whenever we are making a change in the existing system, that change has not broken something, that change doesn't have any ripple effects on the main functionality. So with each iteration, the number of components might keep on increasing, and so does our regression test. So it will be very difficult to do this job manually. So that's why if we are doing an iterative and incremental model, then it is wise to use automated component regression test, because then we can just run the automated test and it can save us time as well, and it can also give us better stable results. As it says that it builds confidence that we can run the automated component test overnight, and in the morning we can see that yes, how many bugs are there. If there are any components which are failed, we can just go to that specific component, see that what needs to be fixed, fix it, then run it again, and then it will be building our confidence. We know that yes, these components are working even after the changes which we have done in this iteration. Okay, next one is test basis. So in this attribute, what we are looking at is that what are the requirements. So earlier we know that test bases are nothing but our requirements. So in this we want to see that what is a test basis? What are the requirements? So the requirements can be detailed design, code, data model, and component specification. So detailed design is something which is required to compare the code against it. As we just mentioned in this one, that we have to that where we did, yeah, over here, that what we are doing in component testing is that we are comparing our code against the requirement, against the design. So over here, detailed design is required as a requirement so that we can compare the code against it. And secondly, code, of course, we need this to run on component. So if we don't have the code, then of course where we will do the component testing. So definitely this is necessary. Next is data model. So if we are doing any kind of testing where we have to test data types or a specific data range, then we need to do data model testing as well. Sometimes we are doing it, but we don't know. Like for example, if we are testing a field and that field should accept only 5 numeric characters, then of course that's something which has been defined as a requirement, which is mentioned, specified in a data model. So many times you must have come across where you are filling in a form, and when it comes to phone number field, and if you enter any alpha character, it asks you that this is invalid, invalid character. This field only accept numeric characters, and sometimes like if the phone number should be 11 digit and it doesn't let you enter 12 digit, or if the starting digit needs to be 0 or something else depending on whatever the country code is, then there are checks which are placed on those country codes as well, just to check that someone has entered the correct, at least the starting of the number, and also the length of number as well. So all these things are identified in data model. And component specification is that because we are testing multiple components individually, we do need the details of the layout of each component, that what are we expecting from that specific component, what would be the layout, what will be the details of that component, so that then we can take that as the requirements and then later on perform our component testing. Any questions on test basis? Okay, there is a question. Okay, Umair is asking, can you give an example of detailed design? Sure, Umair. Let's say that, so you know that when we are doing different stages of any SDLC, I think in the last session we did that. We said that there is a requirement phase, and then there is a design phase, then there is a development phase. So in the requirement phase, let's take an example of this, the same one which we did over here, user registration page. So we have requirements, and let's say in the requirements, I give you the requirements that you have to build a user registration page in which I want 3 high-level sections: personal details, employment history, education. These are high-level requirements, and then of course we can write detailed documents as well. Then comes the design phase. In the design phase, someone can build a prototype where there can be mock prototypes or the blueprints that how it will look. Because right now we haven't built anything, but we can start with any kind of prototype that yes, On the first page, I want only personal details, and then there should be a next button. These fields should be there, and these should be left aligned. And how, like, just imagine that how those personal details will be on the first page. Then there should be a next button. The next button should take the user to the employment history page. So these are all part of design phase. So we are working on the design of those requirements, and then comes the third part, which is development, which is coding. So all what we are doing, what we are saying over here in the retail design is that we have all the design, the retail design as a requirement, because if we don't have those design and we want to test our code against that, then that will be an issue. Because when we are building a code, let's say that if I'm a developer and I know I have the requirements that there is a personal details section, and I'm also working on the UI as well, then I can just start designing it by myself, or maybe the way I will be coding it, then I will not be taking care of like what was specified in design, and I'm just not taking care of all the rules which were identified. So for example, if there was a field in the design, it wanted it to be in a specific order, and in coding I'm not taking care of all those details. Or if there was any condition in the design that let's say that if someone entered a specific title or select a specific title, after that the other titles disappear before they enter the name, if there is a requirement like that. And then in coding, I'm not taking care of that and I'm not implementing that, then there is a conflict between the design and the coding which I have just done. I hope this is clear. Okay, that's good. Right, let's go to the third attribute, which is test objectives. Okay, so now earlier we went through what are the objectives of component testing, what are the requirements. Now we need to know that what we need to implement our requirements. So over here, of course, we need, first of all, components, units, or modules, which we already went through, that the component testing is also known as unit or module testing. We need small units in a software to perform component testing on. So these components will be our test objects. Next is code and data structures. Again, the code as well, that what code we are writing to build that component, that will be our test object as well. The same is with data structures, that if we have a backend for that code as well to support that, if we are using any kind of database management system, then testing that along with the code will be acting as our test objects as well. Third one is classes. So classes is like if we, let's say if we are using C# as our coding language, and we have specified different classes in our code, then we have to test that as well as part of our component testing. So we will be testing all the specified classes. So that will be acting as our test objects too. The fourth one is database modules. Database modules can be linked to the data structure part, which we already did. An example of database module can be that if we have to test a range, a data range or a date range, let's say, then these kind of things will come under database modules. So any kind of data types, or if we are specifying the range of a specific field or specific type of data, then that will come under database module. Okay, so this is all for that the test objects. I hope this one is clear. Fourth is test defects and failures. in this attribute, we see that what kind of defects and failures can be found during component testing. So now, and on each level, we are doing different kind of testing, and the objectives are different, the requirements are different, the objects which are being tested are different, and so would be the defects and failures expected from that kind of component as well. So if there is a component and a developer, let's say, is testing that component, that what kind of defects can I expect? The first one would be incorrect functionality. For example, not as described in design specification. So if anything which is not working in my written code for that component as per the design specification or whatever the design details we discussed and agreed earlier, then that component testing will fail, which means the functionality I developed is not correct. So that can be a type of defect. Second is data flow problems. So if there are in one component, there are different flow which are required, which means that let's say if there are 3 functions and there is a specific order in which those functions will be called or executed. If the flow of data is not correctly coded, then we'll have a defect over there as well. So that can be a type of defect. The third one is incorrect code and logic. Okay, so over here, let's say that if I'm using if statements or any kind of other conditional statements, and the logic which I'm using over there is not correct, then that will be having a defect as well. Like for example, if someone who can register to an application should be of minimum 18 age, is the minimum age is 18, but when I'm writing that if statement where I'm checking the user's age, if I'm just saying instead of equal to 18, I'm using any other wrong operator, then of course that will be the incorrect logic, and of course it will end up being incorrect code and will be a defect. So these are few types of defects and failures we should expect from component testing. So defects, usually when we are talking about testing which testers do, so we always come up with a defect management system where we report the bugs, and then the developer who has built that code fix those bugs and we retest it. But when we talk about component testing, what we are doing at this level is that the developer who's developing the component, he himself is also doing the component testing. So at this stage, it's a very early stage. That's why it's like the first test level. It's such an early stage that at this stage, we don't have any formal defect management. So if I'm a developer, if I am building a component and while building it, I'm coming across the bugs, then I will just keep on fixing it until my component will pass. So I don't need to log that defect formally anywhere. Right, okay. So this is the fourth attribute. The fifth and the last attribute for component testing is approaches and responsibilities. So first of all, we will cover the responsibility part, and then we will go to the approaches as well. So for the question over here is, who is responsible for conducting component testing? So there are two answers. Mostly it's the developer. In most of the places, a developer who is writing their own code, they are doing component testing of their own code. So that's mostly in most of the places. In few places, it might be that a tester would be doing component testing, that a tester is being asked that, yes, maybe the developer, or maybe it depends on the process being used in that company, that a tester would is supposed to do the testing. So if a tester wants to do the component testing, then that tester needs the code to be provided by the developer, because if developer is doing testing of their own code, they already have the developer, they already have the code, but a tester has not developed that code. So a developer needs to provide the code to the tester so that they can test it. One more thing over here, as we covered here, that a suitable test environment is required for each test level. So now as we are talking about this level, which is component testing, so we also need to cover that what kind of environment we need over here. So when we are doing component testing, because it's mostly a developer who is doing component testing, so that mostly a developer do the component testing on his own machine. So he or she doesn't need a specific test environment for that. A local environment is more than enough, because all what we are doing is that we are testing individual components. So it doesn't need an integrated environment at that stage. So it can be done on local machine of a developer itself. Okay, so I think there was a question. No, okay. So we have covered the responsibility, that who is responsible mostly is the developer who is responsible to do component testing. Next, we will cover approach. That what are different approaches for component testing. So over here, one is the traditional approach. And what we do in this traditional approach is that a developer who's doing component testing, what the developer will do, write the code, run that code, maybe find the defects, fix it, and the component testing is done. That's one approach which is usually done. The next one would be TDD. I'm not sure how many of you are familiar with this approach, but TDD is known as test-driven development. So as the name says, this is a test-first approach. And in this approach, what's done, that instead of writing the code first, an automated test is written first. So automated test is written, and then after that, either that test will automatically will fail, because of course that test is written, but then there is no code is written for that, and that test will automatically fail first, and then after that we will build and integrate the code and then run the test. Then if there are any issues, we will correct those issues. Then based on whatever the fixes we have done on the defects, we will refactor the code. We will make the changes in the test scripts over here, then make changes over here, then execute the test. Then if there are still any issues, we'll correct that. And we will continue this process until the component has been completely built and all components tests are passed. So this is this concept of TDD. It is an example of test first approach, and it was originally part of XP, which is known as extreme programming, which is itself is a form of agile methodology, but it is being used in the other forms of agile and the sequential life cycles too. So for this syllabus, we don't need to go into much details of what is extreme programming and what are the other forms of agile. This is a part which is covered more in ISTQB foundation level for agile tester. So this is discussed all in detail over there. So over here, it's just that you should be familiar of what is test-driven development and what's the order in which we execute all the steps. So if we just go through this once again, so when we are talking about automated test scripts, these are basically written by the tester, which means that instead of this approach where let's say the developer is writing the code, executing, finding and fixing the defects, and later on in the system testing, a tester is seeing the code for the first time and testing it. Over here, a tester is part of that activity from the beginning, and where developer and tester, they are working together with each other, and that's why this is a very good approach, very successful approach for most of the iterative models. So a tester write the automated test scripts, then this is the activity which a developer performs, building and integrating code. So they are working along with each other, and mostly in most places this is like worked in a ratio of like 1-to-1. So if there is one developer, then there is one tester working along with that developer, or maybe like 1-to-2 ratio as well, depends on like what the frequency of work being done. But it's a very successful approach, and this is like a reverse of traditional coding practice. So instead of writing the code first, we are writing the test to verify the code, and what we achieve from this is that this really requires us to think, what do you want from the code? And as testers and developers are working together, then there are chances that whatever the misunderstandings or something, misinterpretation of requirements are, those are being resolved. So ideally, yes, this will be done by a tester, this will be done by a developer, but at many places, a developer is also doing the TDD themselves. So they are writing some automated script based on their knowledge, and then they are also building and integrating the code. Okay, I think there are some questions over here. Okay, Sahana is asking, without developers having the screens ready, how does automation script work, or how automation captures objects without seeing getting ready? Okay, so Sahana, that's a very, very good question. So at this point, there are mostly, let's say if we are having a web application, so at this stage, we might not be having the screens, but let's say that we have prototypes. In prototypes means that there we have the UIs, we have the interface, we have the skeleton of the UI, but we don't have any functionality behind that. One option is that we have an HTML page, but we have no functionality. So we can use that HTML page as a prototype, and based on that, we can start writing the test scripts and then start building the code. So if we have a name field, we know that a name field would be on the first page, and we can start our automated script, let's say from that field, and then start coding. First, we write the script that let's say that one of the script can be that it's a text field, and of course there is no code, so that when we will run that test will fail. But then we can write the code and integrate it. So as we start writing the tests, with each test, we keep on building the code. We keep on integrating the code until the component is fully tested and completed as well. This is one scenario. Second scenario, as you said, that, okay, let's say the UI is not there. If UI is not there, but at least the service layers are there. And that's why nowadays, most of the projects, and they are working on APIs. So what is API? That we are working on a service layer. So we don't need UI always to start capturing the elements. We can just start writing our test on the service layer as well, where we are sending one kind of request and we are getting the response back. And later on, once we have that service layer built, then later on we can link it to any kind of UI which is being developed later on. So I hope this answers your question. Okay, that's good. Right. Okay, so with this, we are done with component testing. And before we move to the practice questions, if we have any other question, let's take that now. Okay, so there is no other question. So let's just move on to our practice question. So the first one is SDLC model is not selected based on one of these options. So go through the options and let me know what do you think is the right one. Okay, so everyone has given me the correct answer, which is really good, and it's B, tester skill. Yes, so an SDLC model is not selected based on the skill of a tester, but the other options are the key factors for the selection criteria: project goal, type of product being developed, business priorities. So I included this question, especially the third option, type of product being developed, because I asked a linked question which had this answer in the session 4 assignment, and some of you attempted it incorrectly. So that's why I thought that if I cover it over here, then it will be more clear that what kind of product being developed is one of the main factors to choose an SDLC. So I'm happy that now you have chosen the right answer. So I hope this one is more clear now. Second one is, which of the following is not a test level? Okay, everyone has answered C, apart from one with the name admin. Who has answered B. I'm not sure who's this because I can only see admin at the name. So C is the right answer, non-functional testing. B is not because B, integration testing, is one of the test level. Okay, so everyone who has answered C, that's the correct answer, absolutely. Can you tell me that what is actually non-functional testing if it's not a test level? So Sahana has said performance load testing. Yes, Sahana, you are right. This is non-functional testing. But what I was, okay, Jatin has also said performance and load testing. Okay, so literally what you are trying to explain me that, yes, what is non-functional testing? Yes, it is like part of performance load testing. Umair is saying just to check the flow. Okay, so what I was actually asking was that, as we know that component integration, acceptance testing are test levels. Non-functional testing is test type. So we will do that in detail as well in further sections. But I think in session 2, we did discuss briefly test levels and test types. So though component integration and acceptance are test levels, then non-functional testing is a kind of test type, because on different levels, it will also vary that what kind of testing which we are doing. Maybe we are doing kind of functional testing. And as you said, yes, it's perfectly right that non-functional testing, under that, performance and load testing can come as well. Maybe we are testing something on at a specific test level, maybe integration level or acceptance level, where we can't sign off until we perform non-functional testing. So we need this specific test type at a specific test level. Right. Okay, let's move on to the last question. Which of the following is an objective of component testing? Okay, Umair has given me the answer. Let's see who else has answered. Madhuri has answered as well. Okay, Umair is saying C, Madhuri is saying B, Jatin is saying D. Okay, so that's interesting. We have we have different opinions on this one as well. Okay, anyone else? Okay, Denmark is saying D. All right. Okay, so I would say Sahana has said A. Okay, so we have all the options now over here. So over here, the correct answer is B, and Madhuri has given the correct answer. So well done, Madhuri. Let's go through the other options as well to clarify. Okay, so why the first one is not correct? Validating that the system is complete and will work as expected. When we are doing component testing at that level, that's like the basic level. At that point, only we are working on different isolated components. At that time, system is not complete, and system is not complete, so we can't perform any kind of validation. And what is validation? Validation is something when we are actually executing the planned test as part of our system testing. So system testing is like the level which is above integration. So it's like component testing, then integration testing, then system testing. Yeah, at that point, we will perform this, but not at component. B, verifying that functional and non-functional behaviors of the system are as specified. So this is the perfect answer, as we did cover it. Let's see where. Yeah, over here in objectives. Verifying whether the functional and non-functional behaviors of the component are as designed and specified. So we did cover over here that we have to make sure that the code which we are writing in component testing needs to be aligned with the design, because that's what we test against. So B is the right answer. Let's see the third one. Verifying that all requirements are stable. When we are doing component testing, we are building different components individually. When we merge them together, maybe there are some conflicts and maybe some changes are required in requirements, especially if we are doing it in an iterative way where, uh, let's see over here. Yeah, we did see that if we are doing an iterative model, then changes will be keep on going on each iteration, which means that they will be not stable requirements in this case. The requirements will keep on changing depending on that what kind of changes are being required, or what's the output of each test. Over here as well, if we are doing TDD, if we are correcting any issues over here, then all the time we are refactoring the code, or maybe we are keep on changing the test, we are keep on changing the way we are the code which we are doing, we are making changes, and maybe the change in the requirements are also required based on whatever the defects are being raised over here. So the requirement doesn't have to be stable over here. That's not something which is an objective of component testing. And obviously then D would be the incorrect option as well. Right, so is there any other question you would like to ask for this session? Okay, there are no more questions. So I hope you enjoyed the session. If there is anything which is not clear, please let me know, or do ask in the group as well. And thank you so much for everyone who have joined this session, and all the others who were not able to join the session, of course, due to different reasons. I will provide the recording after the session so that you can go through the recording. And if you have any questions, then yeah, do ask me, and ask each other as well. So I think now is the time where we should be a bit more interactive in the group as well, because that's the main purpose of having the group, that you start discussions. And maybe you should be going through different sample questions on different websites for ISTQB Foundation. We have already done one module, so start to dig some difficult questions and post them in the group, and let's see that who can attempt that. This would be a very good practice. I will also upload the assignment in the group, hopefully by tomorrow morning. And then we will be having our next session on Tuesday next week. So I hope that all of you have a very good weekend, and take care of yourself. I'll see you on Tuesday then. Bye.